Всем привет.
Questions, and I would like to give the floor to you.
Начнем с того, кто такой я.
Let us start with me. I'm Bronislav. I work for Positive Technologies, and I've been in IT
Я занимался
for more than 20 years,
вещами,
and I did different things.
занимался
I
тестированием.
did analytics, I did testing, I did development, but over the last 8 years I've been in data engineering, and that's what I've been attracted to. What are we going to talk about? Today we're going to talk about the history of data formats, why they evolutionized, what are the modern formats,
Apache Iceberg.
and Apache Iceberg.
С давних времен
We'll start with the history.
требовалось сохранять информацию.
People wanted to
Сначала для этого хватало
keep the information, send the information,
пещеры, но количество понятий увеличивалось, количество того
but the number of definitions really increased.
увеличилось, и появился алфавит, появились иероглифы, и это дало
So we have alphabet, we have hieroglyphs,
передавать больше
and
информации.
it gave us stimulus to having more information.
Через стены пещеры или через глиняные таблички стало неудобно.
Passing the
Появились более компактные
playtable tablets was not convenient. We had new options to store information.
много информации.
And of course, the issue was not in just
Повествовательной информации, но хотелось еще
transferring the information, but also people wanted to process it.
появился
And for that,
окончательный вариант отображать информацию в виде табличек. Ну, про это
we've invented tables.
Володя сегодня рассказывал. И тут мы
Vladimir was telling us about it today.
нашему времени
And
к
now
управлению
we
вычислительных
are jumping to
и к
our
желанию
time
эти таблички отобразить
and to computers
в рамках вычислительных машин и использовать новые мощности. Как же можно это
in
сделать?
order to use the
Есть простой
new
вариант.
powers of the computers. We
Можно
had the easiest way of
текста сделать
just
какой-то разделитель, и таким образом уже
sending them as text, just with some separator, and
на самом деле самый
process information from the
широко используемый вариант
CSV.
названия для такого формата это CSV.
The most popular
Множество
name for this format is CSV, comma separated values,
delimited
but
форматов,
the broader
TSV и еще какие-то
term is delimited file.
способом разделения.
Other options would be
используются для
different just in terms of what symbol is used to delimit the elements,
примерно одна. Ну, еще
but the idea is roughly the same.
у CSV, у файла с разделителем
Even CSV,
существует
with a
множество
comma,
диалектов, и связанный
there's a number of dialects
он
because
содержит в себе
the format
проблему, что у нас есть
would
разделитель
have an issue of
самой информации, нам надо
the
как-то
delimiter, the comma,
у нас есть
participating in
разделитель перенос строки, мы можем хотеть
the
указать эту информацию внутри наших данных. В общем,
elements in the data.
как-то надо решать.
So the comma and
Ну,
the
разумеется, есть и другое. Если забить на то, что
new line
формат был человекочитаемый, человека...
will be popular. That's why hence the dialects. We can also use binary formats. So
появился
at the same time with CSV,
форматов, конечно, было гораздо больше.
DBF appeared. There was a lot of binary formats, and DBF is the most widespread,
Уже сохранять данные
and it's still alive.
над тем, как
It allowed us to save data without
для его
minding the delimiter,
нужно было
but to use it,
специальную программу.
you would need a special program.
Программы стали называться системы управления
Such programs would be called database management systems.
DBF, то есть первые
They appeared long before DBF
А в
in the
70-х
60s,
появилась концепция так называемых
and in the 70s, the concept of
данных, и в 80-х годах уже появились первые реляционные
relational databases appeared.
DBase, в котором появился
And DBase, which was the first relational database with DBF,
базами данных.
was roughly from the 80s.
Такой замечательный
And in the 90s,
работы с данными, как SQL, который очень много
new way of working with data appeared
подход к работе
called
с данными,
SQL,
нужен был не то чтобы программист, хотя кажется, что на
because we needed not the programmer,
но
even though you would think SQL is more of programming, but the data availability has dramatically improved.
Понимаю, что это такая капитанистая часть доклада.
Speaking about relational database,
У нас есть множество сущностей, у
you would
сущностей
know
есть определенный
probably
признак,
everything, but
и признак
anyways, we have entities, we have
для того, чтобы связать одну сущность с другой сущностью.
traits, and we can use them to connect entities between each other and create relations.
Является реляционными базами данных принципов, признаков гораздо больше.
Relational databases have more
Да? В правилах.
rules, I think there were 13,
У нас есть отношения,
but the main idea
нам
is
связывать.
that we have relationships that allow us to connect information.
SQL позволяет легко описывать вот эти самые связи, позволяет описать
SQL would allow us to
одна сущность с другой, причем делает это
connect those entities
в читаемом
and
формате,
describe
доступном
how they are connected.
задумке для простых людей.
It's done in a user-readable
Но не
format,
все равно для того, чтобы освоить
but it's not that easy to understand SQL. You need to spend some effort.
Если мы говорим о форматах данных, то на развитие этих форматов
If we speak about the data formats,
задачи хранения данных, но и задачи
then developing them
конечно, будут сейчас такие
would
спорные
need
тезисы, но
to serve not only the data storage, but
передача данных
data transfer.
требования.
But in my opinion,
В случае,
data transfer
используем их в рамках
has
одной
put a lot
программы,
of
в рамках
pressure on
одного приложения, у нас все достаточно просто с тем, как
on the
данные
SQL.
один раз их описали.
If we just write them once and read them by one
Если мы говорим о
program,
передаче данных,
then
то у нас вот эти правила описания данных нужно передавать, нужно
the rules are very simple.
контакт данных, в рамках которого передаются эти данные.
But
Дальше начинается еще одна проблема. Этот контракт постоянно меняется.
if we change the contract, if we use different
Наши пользователи хотят новых фичей,
software,
требуют
if
какой-то новой
the
информации,
users
значит,
require new information,
менять ранее
then we need
сформированные
to change the agreements.
Постепенно растет объем передаваемых данных, а скорость
Moreover,
передачи по сети,
the
они
volume of
возможности хранения на диске. И
data
для
increases, and it increases faster than
это, наверное, задача объемов. Для передачи она на момент начала развития.
then you can grow the storage. So
Ну и, конечно, есть еще вопрос.
transfer was limited significantly,
При передаче данных
and
нужно учитывать, чтобы эти данные
also
были понимаемыми программами, которые
we
их
need
используют. То есть
to be able to understand the data
из
using any program
данные
that
в само
works with them.
приложение и приложение.
So from the integration format, you need to be able to convert
Получаем данные с диска, у нас
data.
есть возможность там прогрузиться, подумать. Когда мы
We can
обращаемся к приложению, мы
load the data from the drive fast, but when we talk to the application, we expect lower latency between the data starting to process and the result being shown.
На самом деле тоже их было достаточно много. Я затрону только самые, наверное, популярные.
There's many formats
Здесь
that
еще такой момент, что очень много использовала свои внутренние
I
форматы.
can show. We've been using a lot of our internal
По многим системам и их
formats, but those formats
наверное, самый такой популярный, когда я начинал работать
are
формат,
popular and used worldwide.
чуть-чуть позже, чем я
The
начал.
most popular one was XML.
Очень удобный
That appeared a little bit later than I started working.
Самое
It's human readable.
данных
Yeah, it's well described.
приложению не нужно даже, наверное,
The application does not need to know
можно попытаться
the contract. The whole contract can be derived from the data,
мы тоже можем отдельно попытаться не согласиться, но
and
тем не менее в этом формате все равно существовала такая
while
как
changing the format, we would
отдельно
have
согласуемая,
data schema
все-таки отдельно
separately agreed
данных.
that would
И тут тоже
ensure
существовала
consistency.
даже не одна такая система описания формата данных,
And there was not one
существовала
system for describing data for XML,
SSD,
but there was also XSD,
и использовался, наверное, больше, потому что он
a format that was more often used because it's more defined. We also had DTD that didn't give all the capabilities. And for some time, I even worked with it, working with Oracle Data Export in an integrator. But as you see, this format is not satisfactory in terms of the data size. So the JSON format is still alive. There's less data. You don't need to repeat the fields, opening and closing. But at least once we need to mention it. JSON is well described, human readable, and it has a separate schema.
Опять же, есть проблема. Мы смотрим на данные, здесь же проще разделить одни данные.
But looking at the data,
XML, но без отдельного
it's much simpler
не можем отделить какой-то тип чисел от другого типа.
Split the data from the format or the numbers, but creating something nested or binary becomes an issue. So those formats have a number of issues. And same as with the storage, there are binary formats. Binary formats are used to, mostly were used for closed systems to interact. But there are open binary formats that you can use for the applications that are not parts of one system, like Apache Avro. It's defined, the schema is mandatory there. You probably cannot create such a data request by hand. The schema is defined by a JSON file. It doesn't work very well with the types, but most of the cases it works very well. So this format is actively used in Apache Hadoop, but its popularization was significantly affected by Kafka. So even though you can send the schema with every message, they are stored separately in schema repository, and this repository actually solved the issue of schema evolution and schema recognition by different applications. This also allowed for the compatibility control between the schemas. It's a great format, widely used, and there's also a protobuf format, also a binary format. You probably wouldn't write those files by hand. Easy to serialize and deserialize, but in terms of the volume of data, Avro is ahead. It's more efficient for the data storage in terms of the size of the message. Given the same structure, the difference is not that significant, but if you have high load, then Avro would be more efficient. Now, with all those wonderful formats of data, we now boosting the amount of information we get. It was originally created by human, but now the software, the applications are creating information. And of course, these increased the amount of information in the world, and we decided to start analyzing and storing and analyzing all the data, but just because there became much more of that, we
point про
Speaking
объем
about
данных, но
big data,
данные
we
характеризуются не только объемом данных, сколько тем, что очень большое
use not only the size, the volume
изменение данных,
of the data, but also the
сколько самих
speed at which it appears. And
когда мы решаем задачу передачи
exchanging.
данных, надо помнить, что
when we solve the
меняются, дорабатываются
data
данные,
transfer
период
tasks,
тоже меняются, и
the
данные,
data
которые мы
is
сохраняем,
being
они
changed,
стали активно
so the
эволюционировать.
data
И
is
эту проблему тоже надо решать. Мы храним одну сущность, но полгода назад она
going through evolutions. We store one entity, but half a year ago it was one entity, and now it's completely different one. So,
данные стали сложнее.
moreover, the
Причем
data
сложнее
is
в плане
more
структуры данных,
difficult
то есть
to structure and analyze.
вариант, когда у нас данные
You
появляются
have
иерархическим. Для этого, правда, есть отдельные базы, но все равно хотели и в больших данных такие данные иметь. Но и кроме
different issues with nested data, and
понятные данные типа строк чисел с какими-нибудь
you also need to compare data like strings and numbers
чего-то для того, чтобы на этом
to images, sounds. So you need to process it with ML.
их решать.
And those new challenges required us to solve them. What is an option here? It's not about nested data, it's more has to do with
то, как мы
a new approach to storage of the data.
срочный подход к хранению
Strings
еще до
are
компьютерной эпохи, он оказался не очень эффективен.
that were used even before
достаточно
the computer era
атрибутов колонок
was not convenient because of the sizes and
полную сущность, а анализировать какую-то
the
часть
need to analyze not the full entity but part of the entity.
по-другому.
So we decided to approach this question differently and store columns rather than rows. This gave us
не только
possibility
выбирать при чтении только нужные колонки и только нужные атрибуты.
choose the columns we need
Позволил эффективно сжимать данные.
and also compress the data.
Данные в строках мы храним.
Because when we store them in strings,
У нас есть там
data is
строки, как правило,
differently formatted.
по своей сути
We have strings, we have numbers, everything is different.
колонкам, то колонки, как правило,
But if we store them in columns,
имеют один тип,
they usually have one type,
в них
and the pattern of data
позволяет
is
более эффективно
often the same.
Ну,
So-
и обсчитывать данные в рамках колонки, как я сказал, когда нам надо посчитать не все
Describe the data in the column,
несколько колонок, выполнить какие-то агрегации по этим колонкам. Удобнее,
aggregate.
читаем одну колонку подряд, а не читаем строки, а потом выбираем из них нужные колонки.
is much easier.
Ну и на самом деле
And
формат, но он, конечно,
very cool format.
но спровоцировал новые проблемы, потому что у нас появилась возможность обрабатывать гораздо большие объемы данных.
Now we can
Ну и
process
тут не спрос родил предложение, а предложение фактически родило.
data in bigger chunks, and it was driven not by demand but by supply. Hadoop was mentioned.
Прошелся по
Vladimir
тому, что
told
есть у меня в
us
докладе.
a great story about
Нам дал возможность
things I wanted to mention also. But Hadoop gave us distributed
то самое распределенное хранение и тоже дал
calculations, MapReduce,
такой
distributed
буст
storage,
в плане того, что на Hadoop, в отличие от баз данных,
and boosted us
проще собирать
greatly
кластера.
to be able to assemble clusters
Hadoop по факту создал нам экосистему для нового подхода к
and creating an ecosystem
анализу данных, создал тот самый Data
to
Lake.
store the data and analyze it, even creating a data lake.
Hadoop, разумеется, активно использовались колоночные форматы.
Moreover, Hadoop
Использовал
also used
ERC. Он утилизировал как раз идею
cloud formats,
хранения колонок
ERC,
в ERC
column storage,
формировались по группам
the
строк.
data in
Кроме того,
ERC
еще
were
ERC хранил такой индекс с данными, что позволяло
storing the index of the data,
его. Но кроме него чуть попозже появился и
improving the
у него
read speeds.
отличалось
And then Parquet appeared.
все те же колонки,
It was a little bit different. Still colon storage, pages, but no index.
На эту проблему, на проблему чтения данных. Давайте немного по паркету углубимся.
Data read
Паркет у нас всегда начинается
idea was different. Parquet always starts and ends with
Дальше
R1.
Очень важная часть паркета — это не начало файла,
Then an important part of Parquet is not the beginning of the file, but the end of the file. Because when you write,
мы можем получить только когда запишем.
the end of file information is only accessible when we calculate everything else. So it has the statistics that allows to understand whether this Parquet is something we need or not.
Группы строк на те же самые страницы.
Then the data is split into strings.
Здесь это row группы.
In ORC called stripe, and here the row groups.
Информация, которая позволяет понять, а нужна ли нам эта
And we have information here
можем ли мы оттуда что-то полезное для себя извлечь.
to understand
Данные.
whether we need this group or not.
У нас есть колонки, и в
As
колонках
part of the row group, we have columns,
и дальше
and they also have meta information.
открываем еще на страничке, и только одна страничка.
And they are split to pages,
Таким образом,
and the pages would hold the data.
учитываем паркет, мы
So
много чтений исключить.
when reading Parquet,
Действительно, если у нас
we
есть
can
выделение только
exclude a lot of read operations,
очень эффективен и без
and Parquet would be super efficient
ничто не мешает
without any indexing.
тоже будет.
But of course, you can put them separately, and that would be a separate discussion.
У нас появился
So
новый
let's move on.
есть
We have a new call.
подход к хранению распределенных данных
We have an approach to
Hadoop, но данных
distributed storage by Hadoop,
того становится больше пользователей.
and there's more and more data,
А,
more and more
Ну и появилась идея.
users of that data. So
вот этот род
the idea is simple. Let's
на отдельные
split the user growth from
синхронно, где-то
the data growth, because they are asynchronous.
нам надо
Something grows faster than something else.
масштабировать наши ресурсы, потому что все, конечно, дорого.
So
А
to efficiently scale the resources, we need to split
у
them.
нас появилась возможность это разделить, потому что у нас увеличились
And we can split them because we have
данных.
more capacity for
И так появились
data
новые
networks.
форматы. Но появились они не
And here's how the new formats
проблемы.
arrived,
Переходим в облако,
appeared, and
и разделяем компьютер.
now when we
Говорим о object storах,
move to the cloud, we talk about object stores,
передавать данные,
about data transfer,
нам нужно загружать данные. Данные загружаются не всегда очень
the
эффективно.
fact that we need to upload the data, it's
Должны
not
описывать то, как мы
always
передаем
efficient.
те данные, которые мы складываем, чтобы эффективно их
We need to repack them, to store them,
решать
and
вопросы функции схем
read them
данными, которые уже сохранены.
well, and we need to
Поля
evolve the data when the new fields arrive, and
данных, потому
we
что в
need
колоночных форматах
update it,
данных это такая очень спорная история, потому что
because updating data in column formats,
всю колонку
we
и переписать файл
would
заново.
imply recalculating the whole column and rewriting it.
Самих object сторов есть.
And of course, object stores would
Когда мы говорим, что вот у нас есть эта табличка, в
have issues with data listing.
которые лежат с определенным префиксом.
Say we have 150 packets, some listing, but listing the data, having that prefix, is an expensive
Не так хорошо.
operation. It worked well in RDFS, but now it's HDFS, but now it's in Parquet. It's expensive. We can write data in multiple threads.
Обеспечивать, допустим, repeatable read уровень изоляции.
And
И надо
we
решать,
can
сказал, проблемы потоковой загрузки, когда у нас
do repeatable read.
данных, они, как правило, пишутся не очень эффективно, не очень
Also with stream upload, we have a lot of data with
маленькие файлики,
small batches,
такая спорная.
small files, and it's always
Появился такой замечательный формат Apache Hudi. Появился он благодаря Uber. Надеюсь, не переврал.
not the best solution.
Он дал нам
Also, we have Apache Store
изменений, которые
appearing because of Hudi.
сложно
We
реализуемо.
have transactional changes that
Каких-то
are hard to implement without
из коробки. Он дал автоматизации, которые позволяли решать
any
проблемы,
special
хранения,
motions. It solves the storage issues, read issues. You can call special commands through Hudi, and it will decide how to write efficiently, how to find Alt-F without rewriting the files, and most importantly, we got data merge and data purge. Hudi stores the data without keys only for up and only, and for all the other types we need the keys. And that's how this table is connected to other tables. And of course, when we change the data, we would merge using that key and update the data. Parquet didn't have it, so you had to implement it by yourself. Besides that, we had an important thing, not that often, which is an option to travel across time and understand what was the structure of the table, and it's done out of the box. So imagine we want to get the data for this specific moment, and we get it. One more thing, Apache Hudi gave us incremental requests to the table without things like last update date. So we can ask it to give us the data from yesterday and get it. So it's much more convenient than the time travel feature. Also, Hudi allowed us to optimize the tables for more read operations or more write operations. So if we have our streaming table, we would have it work more efficiently for write operations. But if it's read more, then it will be more efficient for reading. So it can be tuned. And Hudi keys are controlled globally without partitioning, and this is often an issue. Many systems would have the key as part of the partitioning specification, and Hudi has learned to bypass this issue. And speaking about updates, we have a common mechanism for updates, and it will have its own logic. Your data updates will happen better or faster, or something else will be updated besides your own data. So this is easily integrated into Hudi format. Also, it has solved the issue with simultaneous writes to one table. This allows to manage and control the changes, that they don't break the consistency of data. So looks good, right? Pretty much ideal. But this format is, like an old story about trying to take off with all that crap. So it requires a lot of settings. To understand how to set up Hudi, you need tons of information. And if you do it with the engineering teams, then they are usually created not by the engineering teams, or not only by the engineering teams. So in that sense, Hudi is not a simple thing. And we have an alternative, Apache Iceberg. You have automation, you have tables, you have all the things that you need without writing the new code. You have schema evolution. You don't need to invent stuff. And You don't need to rewrite the packets that are stored.
Также есть обновление и удаление записей. Правда, Iceberg использует концепцию ключей.
You can also update data. Iceberg would not support
Чуть попозже расскажу, как это реализовано.
Update per se. You will just have add and delete data.
Тот же самый time travel.
And also, you'll have time travel.
Еще такая хитрая штука в Hudi.
And
Или нет? Есть
I don't remember if
мы делаем табличку, как правило, мы должны сказать, как она партиционирована. А в Iceberg мы можем
you need to partition a table. In Iceberg, you can say that this table is positioned this way, and now you can switch it, and it can be very convenient.
Ну, по крайней мере, применимой. Чтение в Hudi также на основе
read operations in Hudi, in Iceberg, are based on metadata and formulate the index.
Возможности индексов, ну или я что-то упустил. Но
maybe I missed something.
На основе метаданных достаточно, чтобы эффективное вычисление.
Metadata-based reading is enough to make it efficient. And same as with Hudi, Iceberg can optimize the table for more reads or more writes, and in some way it enables you to implement the concept of repeatable reads. So with a number of requests, you will be able to read the database, and even if the data was not was changed, we need to have a consistent set of data. Iceberg has this opportunity. And another great feature that you'll see later is the data catalogs. I will tell a little bit later about it.
Ну и главный плюс Iceberg из коробки.
And here is the main advantage. Iceberg works quite well straight from the box. You don't need to tune anything up. You have Iceberg, and it works. As far as Hudi is concerned, it doesn't work as simple as that with Hudi, at least with me. What are we supposed to do to have a table on Iceberg? We need to understand that we have a storage for it. We have some object storage, but we do not limit it with S3. We can have it on HDFS, and we can even keep it on our disks. But it's important that the calculating system should be able to connect to it. And there's a compute system that's the one that's supposed to be in place with Iceberg API. Iceberg API is in lots and lots of systems, so it should not be a blocking element. Iceberg API works with tables, not the computer, but the computes. Actually computes this, processes this, and you need to have a catalog. So what's this catalog all about? It's a system, it's a storage of meta information for tables. If we take classic DBs, like system DBs, and its physical structure, for that in Iceberg we need to have a similar information and similar catalog. It contains information about the tables, their structure, where they are, and it allows us to separate them and put them in an environment, in a space. It's called namespace here. What are the options for catalogs here? There is Hive Meta Store, which is actively used by everyone. For a very long time, it's been a standard mechanism, which is used in many cases. Apart from that, we can do it simpler. We can put a database that we select. It should do JDBC. Should create a schema and give access to Iceberg API to this schema. And Iceberg API will do everything needed with this schema and will use this schema in work. But instead of database, it may do something more. complicated. It will have the implementation of MS Catalog. It's an open source tool. We can change it, put our logic in there, and make Iceberg even more fun to work with if we like. And yet another messy, interesting project, right? Which allows us to bring a little bit more engineering touch, programmer touch. It allows you to take a look at this as repository data, a la Git, just like Git. We have it as a very convenient solution. Now let's just speak about how we get the data from the catalog. What are we supposed to do? So we may want to upload data from storage, and computer is supposed to get this data from the storage, should be able to do calculations, should be able to create new tables and upload data to these tables. And ideally, we would like to have it all in SQL so that we give it to our analysts without actually making them write the code. So SQL, I guess, is a standard. And we can use Spark for Iceberg that supports Iceberg API. We can use Spark's query language. We can describe this code the way you like. We can use Hive if you like, which is a nice solution. Everybody just works with it, and it supports Iceberg API. And it's Trino. Trino is a tool which is a new one. It's a virtual database that can address to a store based on S3. It can take files from there and do some calculations and do it for Iceberg API. And if we work with the streaming data, Andrei spoke about that, we have a Flint framework which can also work with Iceberg API. If that's not enough, there is Java, Rust, and Python support of Iceberg to that bigger extent, to a lesser extent. If we would like to do something great, we can do our homegrown, home-written solution. Now let's speak about the storage. Let's speak about the tables. The main entity for Iceberg is the metadata file, which is always the one, and the catalog refers to it. That's the atomicity changes essence. It contains the information about a few snapshots of the table. It has links to the manifest lists that contain manifests. Each stage, we have some statistical information which helps us understand whether we should read each and every step. And from manifests, we have files with data, packets that, like I mentioned before, that contain the data that we insert in the tables. If we would like to change this data, we have a new metadata file, but it will only be sent there when committed to transaction with two conditions, with two snapshots, containing manifest list that will be aware of the manifest paths, with data files of two types of data files. First of all, the deletes, and second, inserts. Separate deletes and separate inserts. To understand how to work with data. So, how do data iterations occur? Because it's the most interesting thing of the Iceberg. We have snapshot, which contains two files of data, the 0 file and file 1. We would like to do some changes with them by changing some of the rights in the first file. We create a new snapshot here. We say that file 0 remains unchanged, so we refer to this and we come up with a new file which contains a new state of data. By getting rid of everything that's deleted, by changing the write at the current state, and the new write-up operations could be added here. So we create copy on write with change data. And we also have this merge on read approach. This merge on read approach allows us to get this basic snapshot. We would like to create a new snapshot. Immediately, it takes data from snapshot 0 and snapshot 1 and creates the file with all deletes, where it writes all of the files that have been deleted from previous files, and creates a file with new writes showing the delta. It's a more economical way of writing. So copy on write when we have a lot of reads. And the second one is when we have a lot of writes. There are two delete options. You can delete it in different ways. There are some positional deletes, and we have equality deletes. So they are much more effective when write operations. It's much more convenient to use them there. Positional delete shows us the path to the file, the position in the file, and the row. And equality delete may do away of it, may do without this.
ID равно 1, например, или что-то такое.
Like RD equals 1. There are some conditions included there, but for this partition there should be a separate delete file, and create some problems. Like I said, Hudi has some uniqueness in the file, but here with Iceberg it's not that simple. And let's talk about the table itself. In the table we have manifest lists. In manifest lists we have the partition spec containing information about columns that are taken into account with partitioning. There are few partition specs. It's a very logical split. There's no standalone file created for specifications. But in manifests, it's stipulated that for this manifest, we have such and such spec. And then in the manifest, we divide it into partitions, and data files either related to such and such, to this partition or the other partition. Separately delete files and separately insert files. So what does Iceberg give us in terms of managing the storage? It's also a very important point. We don't want to mess with this bunch of files that we created. Iceberg allows us to delete unnecessary extra snapshots when they get expired. Some relevant snapshots are also kept, and we run this command which will delete everything which is rendered obsolete. It also allows you to get the files reassembled, optimizing the size of the files. When there are plenty of small files, it's not always convenient, but Iceberg allows us to do just one operation and without actually making you think how to do it. It will do it in the most efficient way. Sometimes the dropped files fail, and they are dropped. We are supposed to do something with these dropped files, and there is a special procedure provided to brush up the table from the dropped files, and it automatically cleans this up. You can do it in maintenance, so that avoids maintenance issues. And now we do the optimization of manifests. We don't need to reassemble the data files, but we would like our reads to occur quickly, and we can do it just to maintain the better efficiency of read operations, so that we address different files not so frequently. So here's a nice set of additional utilities which will spare you from writing extra code. I've described everything that Iceberg has, and now I'm open for your questions.
Брон, спасибо. Обязательно сканируйте QR-код. Брон очень старался.
Bron, thank you very much. You must scan the QR code
А можно там QR-код?
because Bron did
Пока нет
all the
вопросов,
best.
зала.
We don't have questions here on the tablet, but we will take your questions from the floor.
Спасибо за доклад. У меня
I'm
вопрос
the first here with a question.
про use case использования.
It's a question about use case of the Iceberg format.
Когда мы стримим данные в
When we
Iceberg,
stream
большое
the
количество
data of the Iceberg, we generate a lot of metadata files, a lot of screenshots are generated.
Iceberg вместе со стримом.
What's the best practice of using Iceberg together with streaming when you stream?
Конечно, и проблемы, то, что действительно создается очень много...
Yes, that's a problem. A lot of snapshots are created, a lot of small size data files.
Merge read.
So you obviously use merge and read,
Контролировать, сколько у вас файлов.
but it's important to control how many files you have and the condition, the state of the table.
Метаданным, причем
You can address metadata through computes. Through computes, you can see how many files you have, how many manifests, and you need to very timely
самые сервисные операции,
pull out the service operations, compressing the files, decompressing the files and making them bigger, changing their size and deleting all the snapshots. That's what we did. Every hour, for example, we would do delete snapshots operations and optimize operations, and it solved that problem. But if you ask Andrei or Dmitry Zuev, they will give you a better and bigger answer. They know more about it.
Скажите, пожалуйста,
Hello, thank you for your presentation.
сценарии использования
What are the main scenarios of the time travel functions that you consider to be practically used?
Для меня тоже такой очень
For me,
сценарий.
it's a dubious scenario, I think. I like this idea that thanks to this time travel, we can fix ourselves in the space,
Начали нашу
and do
операцию.
the repeatable read. We start our operation
Данные, вот, которые были
at 12
и
noon, and we're interested about the data
длинная.
after 12. I mean before 12, not after. And our operation lasts for a long time. And this use case, well, it's hard for me to imagine it. I think it's a perk that allows you to evaluate data and all these side effects, like fixing the snapshots
Забор данных из таблицы, это тоже
and do the incremental
то есть мы хотим сказать не то, что у нас
picking of the files. It's additional.
какой-то даты, а
We would like to see something not before a certain data,
нашим ETL дальше
but
были после определенной даты, потому что
we will see the
мы уже загрузили
data after the certain date. And we don't need to think about what kind of data this table contains. We have a system attribute which will only take the new data, not the old one. I think Databricks based it on time travel, and they did it like time travel option. Any other questions?
Ну, тоже хотел задать вопрос
Well, it's also a question about
по Data Travel. То есть, получается,
about data travel. So
системный,
it
который
seems like that this is a system
всегда
option that you can use with inquiries, with queries. Yes, now it's getting convenient when you would like to check for
все события, которые идут по времени.
да, можно
security breaches, vulnerabilities, attacks.
таймлайн изменений
Yes, you may get some
этого.
timeline of the changes based on that. And you will see the changes on this timeline.
Дельта.
Дельту,
What about Delta? Did you compare it with Delta?
когда, ну,
No, I didn't compare it like that.
как раз между Худи и Айсбергом.
When I chose between Hudi and Iceberg before the positive, at that moment Delta was,
Вот.
you know, restricted.
Это было еще там какие-то ранние годы.
I think it was back in the early days when we didn't even have any problem with the clouds.
Отказаться
But I
от
think
это было правильным решением, потому что
dropping Delta was the right
были
decision,
определенные проблемы.
because otherwise we would have had problems. However, these days Delta is not so restricted, it's becoming more open.
Используется.
I didn't check it for a while, but it uses similar ideas. Thank you.
Насколько я понимаю, вот, ну,
As far as I know,
айсбергу, да, то есть
this iceberg approach is using
таких вот форматов,
standard formats like Parquet, ORC together with Manifest.
собственно, вот вопрос
Exactly,
по
exactly.
использованию
So here is a question about
баянистых форматов
using
Parquet ORC.
them,
Вот как получается,
Parquet and ORC, that are so popular.
Parquet относительно ORC, да, например, удобно.
What's the advantage of Parquet over ORC? I think it's more convenient.
Many, write once, типа вот такого.
Read many, write once. These are the things.
Преимущества
Versus ORC, they are advantages.
вот в Iceberg.
And what about these advantages over Iceberg?
Слушай,
Like, what's best for me to use if related to Iceberg?
мне кажется, что
Well, it's a complex question. It's hard to answer simply. I think in some of the scenarios there will be the difference. There will be difference.
Сценариев, которые я видел,
But most of the scenarios I've seen,
скорее всего,
ORC is not even checked up, and most likely they use Parquets.
ты правильно сказал, что
You are quite right when saying that in the read-write scenarios we
есть разница.
write more and read less. There is difference, but also there is difference between the volume of storage between ORC and Parquet, but it's not so critical. But honestly speaking, everywhere I've seen, Iceberg is more often used with Parquet.
Да, в
I
продолжение,
have not seen the scenarios of the use of the Iceberg with RC.
в принципе.
So there is no issue of cost of the storage. Yes, there is such an issue.
Хранение есть. Ясно, что у нас
There
есть
is cost of storage, and we have some cloud solutions which reduce the cost of storage.
но все равно
They mitigate it, but still,
конечно, очень эффективный в плане хранения.
Parquet is very efficient in terms of data storage, as is.
Ничего нового не
So Iceberg is not creating anything new
но все равно
for that matter. But you just need to think about your storage space all the time, especially knowing that Iceberg uses snapshots and they also steal some space, storage space.
делать.
Especially if you make a copy in write, it takes some space, especially if you store these snapshots for a long time. It takes volume. One more question. Is branching inside Iceberg works only with Nessie? What are other use cases apart from tuning the KKD for the last branch before it merges with the table? What else can we do? Have you ever tried working with branches?
Вот посмотрел только
With Nessie,
красивую идею. На
I
самом
only just checked this beautiful idea.
по-моему,
And
есть
the idea of tags and branches does exist in Iceberg, but it is fully fledgedly introduced in Nessie. However, there's yet another problem with Nessie, with the branches.
Iceberg очень
Currently, Iceberg
многотабличных
is very bad with multi-table transactions, whereas Nessie tackles this efficiently.
и без него. Я так понимаю, что
So without it, I think it is resolved in some custom-based catalogs, not in half-meta store,
GDBC каталоги или
not in the base GDBC catalog and such like. So Nessie resolves these issues well, or you resolve it through your own catalog. One final question,
Потом можно Брона помочь.
and please take all the other questions to the sideline.
Именно Iceberg.
Where do you recommend to use Iceberg specifically, and where Iceberg is bad? Where are the stumbling blocks of using Iceberg? Well, my presentation obviously shows it seems like it's a very
но
all-round solution, an all-round solution for all of the problems. Iceberg, I mean, but you know, around Iceberg there are plenty of additional files created additional information,
ну, и это определенная проблема.
and it proves to be a
У
problem.
нас в ряде случаев файликов
Because in some cases,
эта проблема, например, в
we have enough of other files created,
с проблемой name-нодов кажется
and there may be some problems with name nodes.
сложность.
There may be such problems
Еще
with
есть
name nodes.
проблемы с ним.
What other problems can I mention related to Iceberg? I think for OLTP scenarios, it's a bad format as is, but I think it's obvious because it's created for analytical
Сложный
purposes.
вопрос, я так что-то не смогу собраться.
You know, it's a very hard question.
Подумайте, в кулуарах ответить.
Maybe you should take it on the sideline. Yes, you will have time for that. It's time for you to select the best question you've heard. Well,
Тяжело, вот
it's very hard
там молодой
to do.
человек спрашивал
I
про
think it was that Nessie-related question asked by that young man.